Okay, here. So this is going to be a video that is designed to help people who are having trouble getting started with the MIPS labs, of which we've had 3 or 4 so far. So first thing I want to do is in the modules page here, you can see that there are some pages on MIPS and Mars. And yeah, you can find those like Lab 10, MIPS 1, Lab 11, MIPS Lab 2, down here MIPS Lab 3, and then down here MIPS Lab 4. Also, we've had the Zybooks, which is also going along with MIPS. Now, in any of the recent weeks, so like if I click week 14, for example, which was last week, then you should be able to find links, specifically this link here, the one that says MIPS info, MIPS reference charts. That's linked in several places now, and I'm going to go there first. So before we even look at a lab, I'll click there. Okay, so this page here, which if I do the student view, maybe it'll look a little different, not much different. And so this first page here where it says Mars Simulator is trying to help you get started. So if you look at the first instruction, it says you need to download Java. That's because the simulator that we use for MIPS assembly requires Java. Okay, so you just have to have Java. Now the computers that we have in the classroom do have Java, or at least we can get Java on them. And so, you know, if you're on your own computer, then it's up to you to get Java downloaded. Now that's not the same as downloading Eclipse. Eclipse includes its own Java version, and we can't run the Mars simulator through Eclipse. So you need to download Java first unless you already have Java. Now the way that you'll know you have Java is if you go to a command prompt, which if you are in Windows, you get a command prompt by clicking the start menu. I'm going to have to type this. Hold on one second. So in Windows, to get a command prompt, your instructions would be basically click the start menu. Then while that's open, start typing command prompt. Now, while you're typing this, the suggested programs will be popping up, and you'll look for the one that says command prompt, which will be kind of a black box looking thing. And then when you see that, then you want to run that. Okay, now since I'm using a Mac, that's not what I do. What I need to do is I need to open the terminal app, which is in my applications. So if I don't know where that is on a Mac, I would have to open the Finder, and then I would go to applications, and then in utilities, that is where terminal is for a Mac. Now, regardless, when you open it up, you'll get, whether it's command prompt in Windows or whether it's terminal prompt here in Mac OS, you're basically going to be looking at a blank screen with a cursor that you can type something at. So like something like this. It will look pretty much the same in Windows and Mac, but of course this is the Mac terminal program, and in Windows you'll be using the command prompt that they have. But if you just type Java there at the command prompt and hit enter, you should see something like this. This is showing you that I do have Java installed. If I had something that was not installed, like if I do that, which is not a real command there, then here it says command not found. The message is slightly different in Windows, but still it'll tell you that, you know, you're trying to run something that doesn't exist. So if you do not have Java, you need to download Java. So there's a link here to download Java. Just goes to the official site for Java, and we just want any of these. So Java JDK 23 is the newest version. You select your operating system. After you select your operating system, you download an appropriate file. So in Windows, for example, I would download the x64 installer. This is the one that I would want. Again, I have a Mac and also Java is already installed, so I don't need this for anything, but I would download one of these two links and get started. Now, if you have trouble with that, then you need to install Java. Look up how to install Java, like on YouTube, and follow a tutorial there if you need to. But we do need Java installed. So that's your first thing, is make sure that you have Java on the computer. You probably, or not probably, but you may have Java installed if you have previously taken a Java programming class, for example. So not everybody needs to do this. All right, so we do that. So after you run the command prompt, we want to type Java, press enter to see if Java is installed. If not, follow Java download link and download and install Java. All right. And again, if you get stuck, you're just going to have to look up a tutorial. So I already have Java installed, so my job there is done. So going back here to this page, again, this is MIPS reference charts page. Then the next thing we need to do is we need to download the MIPS simulator. Now, don't miss this link up here, by the way. There's a free textbook you can download where you can read a lot about MIPS. So that exists. So just know that that's there. Then we want to download the Mars simulator. So the Mars simulator is on this website. And this is just a GitHub page where this is the releases page of that. So we want to download this file, the one that says Mars 4.5 jar. So it's a jar file. So you need to download that. So we just click it. It downloads. Okay, so that's all you need for Mars. So we made sure we had Java, and now we've downloaded the Mars simulator. Okay, now to run the Mars simulator, we basically need to type this command in: java-jar mars4_5 jar. Now the thing about that is this file name is going to be path sensitive. So the way that I would recommend you do this, and again, this is going to look a little different because I'm in Windows, but the idea is exactly the same. So what I would do is in the command prompt, wherever you are, you start typing this command. You type java-jar, java-jar, space. Okay, java-jar, space. And then this is where we put the name of that jar file that we just downloaded is. But you need to know what folder you're in and all that. That's a little bit tricky. So what I would recommend you do in Windows or Mac is you open a file manager. So in Windows, that's Explorer. In Mac, that's Finder. So I open up Finder. And so this is my home folder. Maybe I can make it icons or something. So this is my home folder. I go to my downloads folder, and in my downloads folder, I can see this file here, mars4_5. So what'll happen in Windows and Mac is when you drag that file over to the command prompt, it'll just kind of put in the location of that file. So here is what it did for me. Again, same deal in Windows and Mac. You just drag the file over from an Explorer window in Windows and you'll get the same effect. So you type this part yourself, java-jar space, and then just drag the file over after that. And when you run this, it should run the Mars assembler with, Java. So you get something like this. And that means that we've successfully run the Mars simulator. Okay, so you need to get to that point. So in order to get to that point, you have to have Java, you have to download the Mars simulator, and you have to successfully run this command. Okay? So that will get the simulator open. So here it is. Now to actually start writing code with the Mars MIPS simulator, you have to create a file. So like right here, we're not looking at any files or anything, but this is where we're going to write our code. So to create a new file, you just do File, New. Oh, you're killing me. So let me figure this out. This is something that happens in macOS sometimes, where it doesn't want to make this big enough to see. Like the actual text editor window is being hidden, and there's a way out of this. I just don't know what it is. Maybe that'll work. Well, here? I don't know what just happened. Why is everything blue? All right, I'm gonna have to close this, open it up, and we'll get it one of these times here because I don't want to start over on this video. Okay, File, New. No. Dang it. Oh. Now it's working. Alright, I have no idea what I just did there. I just banged on the keyboard and this started up. Okay, so sorry about that. Like I said, it's a little bit weird in macOS. Like sometimes it doesn't want this window to pop up here. Let me just close these files real quick. Close all. Uh-oh. Yeah, do it. Oh no, don't save it. Just close it. Sorry, I'm just looking at the folder there. File, close all. You don't have to do this. This is just me. Okay, so this is working. So again, sorry about that, but we're back to where we were. So when you create a new file, it'll be called MIPS1 because it'll be the first one, not the 7th one like I have. And you have a text editor window here. And this is the start of a MIPS assembly language program. And so this is how you get started here. Now, at this point, maybe we want to have an exercise to do. So I'm going to go to the modules here, maybe in a new page, so we can keep the reference page up. And let's take a look at one of the MIPS assignments. Now, I don't know if I want to look at MIPS 1. Maybe we can do MIPS 1, I guess. I don't know. I was thinking maybe we would do a harder one. But what am I looking at? Yeah, let's look at MIPS Lab 2. So I'm going to look at MIPS Lab 2 instead of 1, just because. Notice that I also have a link to that MIPS reference chart pages there. So yeah, so we'll download this, the PDF. Hopefully it downloaded. It did not download. What is, no, download. What are you doing? Okay, now it downloaded. All right. So I've got here MIPS Lab 2, and let's get started here. So it has some kind of basic instructions here. This site, this is where we used to get the Mars simulator from. As of about 3 weeks ago, this site was taken down. So like on the day that we did our first lab, this site existed, and then when we did MIPS Lab 2, the site was already gone. So this link does not work anymore. So yeah, you'll have to rely on the page that I've written. Okay, now it says this is a simple program to remind you how the instructions work. Rather than look at this sample program, I'm just gonna write one. So let's go back over here. So we're in a text editor. Now, MIPS has two sections. So you write .text, and that's where your code is going to go. And I'm going to leave just some blank lines, and you write .data, and this is where data goes. So all of our code is going to be in the text section. In the data section, we use it for holding things like strings. For example, let's say I want to write this string. I'm going to print this out in my program. I'm going to say, I want to print the string, hello, my name is Greg, right? So there's a string there. Now, you can't just put a string like that. We need other stuff here. So first we have to give it a name. So like I'll call it string 1, but you can call it whatever you want. And then you need to say what it is. So it doesn't know it's a string right now. So in order to make a string, you write .ASCII-Z. So this is the label. This is what the type is. And this is the string. Notice there's no semicolons or anything on here. Okay, so there we go. That's the string. And if I need a new line after it, I have to type that myself. \n for a new line. All right, so that's just a string. Now, this program doesn't do anything right now because I haven't written any code. So first I'll save it, file save. Sure, save it wherever, I don't care. And then run it. So I'm gonna do run assemble, and you get a bunch of stuff up here that you want to understand. And then you do run go, and your program runs at that point. Now nothing happens here because I haven't actually written a program yet. So I click back up here on edit to get back to my code. So if I want to print this string down or print the string out in the console, we have to use what we call syscalls. So syscalls, I'm going to type it. Syscalls are the way you ask the operating system to do something for you. This is just comments here. For example, printing a number, printing a string, which is what we're about to do, reading in a number, etc. Okay, so syscalls are how we do a lot of things in MIPS assembly language. So you have to go over here. Let's find our MIPS reference charts. So this is the kind of introduction page, and you go to syscalls, system calls, as it's listed here, and this is a list of all of the system calls. So what they do is the operation here, and you can read what they do. So there's a system call for printing an integer, a system call for printing a number, a floating point number, another one for printing a floating point number, but these are for float, and one is for double. Printing a string, reading an integer from the user, reading a floating point number from the user, read a 64-bit floating point number from the user, etc. Right? So we see these different things that we can do. Now, in order to do those things, you have to have data in the correct registers. So I'm going to click on registers up here. So all of this stuff is covered in the notes and in the Zybooks, and also that book that I suggested, which is over here. This was the free book that's linked in various places. I can open maybe table of contents. I don't see the table of contents, so I won't worry about it. And if you go to chapter 2, first programs in MIPS assembly is in chapter 2, and this will have a lot of the same information that I'm talking about here. So this will be like, you can see there's a picture of the Mars simulator in Windows, and they'll talk about how different things work here. Now, what we need to understand is that on the CPU, there are registers. Registers are memory locations that are on the CPU itself. So the CPU has 32 of these registers. This CPU has 32 of these. Different CPUs have different amounts, but our processor has 32, and they have names. So this is just a big chart of all the names of them, and they have purposes. And so this is all indicated in the same chart that I have on my page. So there's one register called 0. Its only job is to be 0. There are these registers that are called V0 and V1, and they're used for returning values from subprograms usually. There's A0 through A3. Those are used for passing arguments into functions. There are T0 through T9. Those are for storing temporary values. So we use those a lot because they're just for general usage, and so on. So these are built into the CPU. Now going back over to the reference charts here, you can see the same information in maybe an easier to see format. So there's these V0 and V1, A0 through A3, T0 through T7, etc. So these registers are memory on the CPU. We can load data into those locations, and we can read from those locations. Yeah. So if we want to print a string, right, that's what we were trying to do. We were trying to print this out in the console. How would we do it? Well, going back over to here, and we look at our system calls, it tells us that to print a string, right, print out a null terminated character string, that's what we have. It says here, it says code in V0 needs to be a 4, right? So what that's telling us is that in order to print a string, we have to put the number 4 into this register V0 on the CPU. That's what we need to do. So to do that, this is where our code goes up here in the text section. We want to put a 4 into V0. So the way you do that is you type li. That instruction is load immediate. That means to load a number into a register. Then you put the name of a register. Where do we want to load the 4? Well, we want to load the 4 in V0. So $V0 is how you write that. Then comma, and what do we want to load in V0? Well, we want to load a 4. Right? So this will load into V0 a 4. Okay? Why do we want to do that? Because that is what it says here to do. To print a string, we put a 4 into V0. Okay. So that's the first step. What else do we need to do to print the string? Well, according to our chart, there's this right here. It says A0 needs to be the address of a string. Address of a string. So what we have to do is we have to load an address. Well, this li instruction is for loading numbers. To load an address, it's an instruction called la. La. Now, what are we loading into? Well, we need a register. Back over here, the register we're looking for is A0. So you type $A0. Now, what are we loading in A0? It's supposed to be a string, the address of a string. Now, the way you do that is you refer to it by the name. So I called this string 1. So I would put string 1 there. Okay. So these two instructions here, these two lines of code, this one puts a 4 in V0. This one puts the address of string 1 into A0. And then finally, to actually make the system call happen, because remember, the reason we're doing this is because we're trying to do a system call. The way you do a system call is you write syscall. So these three instructions together print a string. Okay. So I'll save this again, file save, and I'll run it. So first I have to do run a symbol. Then I have to do run go. Where's the result? You're killing me here. It's down here. Come on. Please. Okay. Hello, my name is Greg. Can I get back to where we were, though? Yeah. Hey, it worked. Okay. So we got the... How did I do that? Okay, so I still can't move that, but at least we can see the result there. So hello, my name is Greg. So we were able to successfully print a string. To get back to our code, you click edit. All right, so we did that. If you had other strings that you wanted to print, again, you can call them whatever you want. You don't have to call them strings. So I could say like message : dot ASCII z, and I could say this is another string \n, right? So if I want to print that string, I can copy the same code and just change the string 1 into message. Save it, run it, run, go. Come on. Let me click. And you see this time we got both of the strings printed. Okay, so that's how it looks when we're printing strings here. All right, so we need to know more instructions. So we need to start learning about the instructions. So if you go to common ASM instructions, this really should have had the name of the instruction here, which it doesn't. But so we've already seen this instruction, which was load immediate. I should have said that this was called load immediate. But that loads a number into a register. We've seen LA. LA loads an address into a register, so that's why it's LA instead of LI. Also, you can move things from one register to another with the move instruction. By the way, this is the destination. This is the source. So this command here moves whatever was in T1 into T2. So those are memory locations on the CPU. These are registers. All right. Now, we're probably going to need to do math. So click on common math instructions. So basically, all your math is going to be like commands like this add instruction here. So what this is showing you is if you want to add a number, the 2 that you're adding comes second. Where you want the answer to go goes first. So like add T0, T1, T2 is the same as if you typed like T0 equals T1 plus T2 in another operating system, in another programming language like Java or C++. Now, there's also versions that have this extra I on the end, like add I. And what that does is it lets you add a number that you're going to type. So the difference is this one up here has 3 registers, and this version here has 2 registers and a number. Okay. And then you can also subtract, and you can multiply, and you can divide, and REM is for the remainder. Right? So just to show you this, let's go back over here, and let's just change this a little bit. So let's just put the answer is : Okay, so that'll be the string we're going to print. All right, actually, let's just print it. So this is going to print that string out, right? So it's going to print the answer is. And now let's try to print a number. So maybe let's add some numbers. Okay, so what do I want to add? Maybe I want to do this. Maybe we're going to add 4 and 5, right? And if we add 4 and 5, that's going to be 9, of course. Let's see how to do it. Well, first we could put these numbers into registers. We know how to do that because we have the LI instruction. So LI, a register, T0. What do I want to load? Let's put in a 4. That puts a 4 in T0. Now let's put a 5 in another register. Into T1, let's put a 5. Now, why am I putting things into T0 and T1? Because those are the temporary registers that we're allowed to use for whatever we want. So we may as well use them for this. Right? So I got these two numbers in registers. Now I want to add them. So add. The first register you put in is where you want the answer to go. So if I put T2, then that's where the answer is going to go. And then what do I want to add? I want to add T0 and T1. So we should have a 4 in T0, a 5 in T1. So when I run this command, that should be putting a 9 into T2. Okay, so we added some numbers. All right. Now, after we add numbers, I want to print it out, right? Because I'm going to print out the answer is, and then I want to print out the 9. How do we print out a number? Okay, well, we know how to print a string, right? These 3 lines print a string, but that's not how you print a number. So you go back to your charts, and let's go back to system calls. And we see that if we're trying to print an integer number, that's actually the first system call, print integer number. So to print an integer number, we look over here on the right, and it's almost the same as printing a string. It says in V0, we want to put a 1. So it's a 1, not a 4, right? So it was 4 for a string, 1 for an integer. So we can do that. LI to put a number into V0, and let's put a 1. 1 because that's how you print a string. All right, and then looking further to the right here, it says A0 should be the integer to be printed. So for string, it was this, right? A0 was the address of a string in memory. So we had to use load address. This says A0 is the integer to be printed. So we just need to put the number that we want to print into A0. That's what this says. So print out a number. So basically V0 needs to be 1 and A0 needs to be the number that we want to print. Okay. So we already put a 1 into V0. Now we need to put the number into A0. So how? I can't, I could do this, right? Like if I do LI A0 9, yeah, that would put a 9 in A0, and 9 is the answer because 4 plus 5 is 9, but then I'm not using the result, right? I actually calculated this up here. I don't want to put a 9 in here because I type a 9. I want to put a 9 in here by taking the answer that's in T2 and printing it. So this is not the right way to do it. So what to do is up here, it says that we put 9 into T2, right? So T2 has 9. But if I print it, I need A0 to be 9. So that's where you use this move instruction. Move. So if I want to put the number into A0, I do move $A0. And then what do I want to put in A0? Well, I want to put the 9, but the 9 is in T2, according to this line, right? Because we put our answer in T2. So I should move T2 into A0. So that'll put the 9 into A0. So at that point, the V0 will be 1, and the A0 will be 9. So this is setting everything up. Then to actually do a syscall, we have to type the word syscall. Syscall. call. Okay, so this is how you print a number. So a little bit different than printing a string. So I save this again, I assemble, and I go, and it ran, but I have to open this up because Mac's not working very well here. Anyway, you see what it says? The answer is 9. Okay, so this is how it's going to be like when you're starting, and we're looking at the first things you can do. You need to learn how to print a string, you need to learn how to print a number, and you need to learn how to add things together. Okay, now I'm not like suggesting this necessarily, but I am going to say that you can ask ChatGPT about this and it knows some. So like if I go to ChatGPT real quick and I could say, write a Mars MIPS. So MIPS is the type of CPU and Mars is that program we were just running. So it's a good idea to include both of those keywords if you're going to ask for help on ChatGPT. So if I say like write a Mars MIPS program to read a number from the user. Actually, how about read 2 numbers from the user, add them, and print out the result. And so this is just an example here. They're going to do some stuff that I have not done, but you'll start to recognize what's going on here. They will explain it, but so like looking at this, for example, you can see that they have their data section first and their text section second. It doesn't matter. See, I put my .text section at the top, and then I put my data section at the bottom. Doesn't matter. So this is where they put all their strings. You'll notice they did exactly the same thing that I did, right? You put a label, they put .ASCII, they put the string. Okay, now they have this here, global main. They're just kind of writing a more complicated function. You don't have to do that. Also, you don't have to put this main. That's just a label. It doesn't actually do anything, but they're kind of showing you where your main program is starting in case you care. So these are optional, these 2 lines, and then you can start to see them doing exactly what we just saw, right? So you load a 4 into V0, you load a string into A0, use syscall. That's how you print a string. Then you want to read a number. Here's what they did. LIV05, syscall. Now, if you look at this, right, we haven't done this yet, but if you look at this here, LIV05, syscall. So we've seen this line before, right, but with different numbers here. We used a 1 and a 4. This time they're using a 5. Well, if you go back over here to your reference charts, and we look to see what is 5, right, because they're numbered 1, 2, 3, 4, 5. 5 is right here, and you can see, look at that. Read an integer number from the user. So ChatGPT is running this system call. They're going to read an integer. And if you look at the instructions here, you don't have to put anything into A0, but your answer is going to be returned in V0. So that's a little bit weird. So you're going to put a 5 into V0, and then whatever the user types in is going to be in V0. So the 5 is not going to be there anymore. The number that the user types in is going to be in there. So they read an integer by putting a 5 in V0 and then syscall. And then in order to move that number somewhere for safekeeping, they use a move instruction. So they're moving it from V0, that's the number that the user just typed in, and they're putting it into T0. And they're using T0 just like I did for kind of putting numbers in. right? So looking at this, they're printing out a message to tell the user to type for a number in. They're reading a number from the user and they're putting the number into T0. They're printing out a message telling the user to type in another number. They're reading another number from the user using that same syscall, the one with a 5. And then look at the move this time. So previously the move instruction was putting the number into T0. Here, they're putting the number into T1. So now they've got the numbers in T1 and T0. Then they want to add them. So this looks just like our add instruction, right? Where we did T0 plus T1 and we put the answer in T2. They're printing a string. They're printing the result string, which up here we can see what it is. It's going to say the sum is. And then they're going to print the number. How do you print the number? Well, you put a 1 into V0. You put the number into A0 and you do syscall. Now, these last two lines are not something I've done yet, but this is the proper way to end a program. So, like, you can take these two lines here and just at the end of your program, you can just do them li B010 syscall. That ends the program. It ends when it gets to the bottom anyway, but this is the right way to do it. All right, so anyway, we covered a few things there. Printing a string, kind of basic math, printing a number, ending a program, and I didn't do it, but to read a number from the user, it's also 3 lines, but it's syscall number 5, and you have to put the number from V0 to wherever you want to save it for later. All right, so that's going to be it for this video. Hopefully that got you started. Again, what you want to look at is on most of the labs. On most of the labs, you'll have a link to this MIPS reference charge page. Maybe not the first lab, but maybe lab 2, 3, and 4. Also, on the current home page, MIPS reference charts is right there. Okay, so that is where you get most of your information for MIPS. Do download this textbook because you can refer to it for help. And also, you know, like I said, ChatGPT knows how to do some of this too. And yeah, also the zyBooks will be teaching you some of this, although not in the order that it's in the labs necessarily. All right, and again, all these tabs here are going to show you different stuff that you might want to look up. Okay, so that's going to be it for now. I'm going to stop this video and upload it for you.